Very good evening to all my lovely students. How are you? And welcome back to the YouTube channel Shri Chaitanya Institutions. So I hope you all are doing well and you have enjoyed yesterday's class, and every day you are learning something new in all 4 sessions. There is chemistry, zoology, physics and botany. And I hope that coming from class 10th to 11th, your transition, I'm sure it is going to be smooth because you have started with the bridge course. So you're already, 2 steps ahead of all your other friends. So very good evening and a very good Friday to all of you, being a festival today. So we'll be, enjoying this together most probably the next year or whenever you come to the campus. Okay. Yes. Good evening, Kulusam, Sri Devi. Good evening, Aradhya. I am good. How are you? Sunita, Rani Reddy, Software KT Vlogs, Vani, Pallavi, KRK, Lasya, Anivesh. Very good evening. Joshika, hi. Hello everyone. So you have gone through any surgery? Small little surgery, a tooth extraction and a little bit of cyst extraction. Good evening everyone. Akisheti, Varun, Krishna, Jaswant. Okay. Thank you. Good evening. Happy Good Friday. Yeah. All right, guys. So before we start the class, you know the first drill. Click on the like button. 200 people, 200 likes. Then we start. 22 likes are there right now. Once they reach 100 plus, we'll start. Yes, Software KT Vlogs, I'm taking all good. Okay, good evening, Lakshmi. Okay, all right, guys. I won't be able to take every name, but very good evening to all of you. Okay, let us start, everyone. So yesterday we have started with stoichiometric calculations. Stoichiometric calculation means, calculation of moles, mass, molecules or volume of any reactant or product in a simple chemical reaction. Is yesterday's class crystal clear to everyone? Once you put a crystal clear in the chat box, I'll start my class. Is the last class crystal clear to everyone? The very first type of questions we have done, where one of the thing is given, other is asked. Sidhu, okay, no problem, Sidhu, you can look at the class. If it is crystal clear to everyone, just mention CC or crystal clear. Just mention CC in the chat box. CC means crystal clear. And then today we are going to talk about the limiting reagent related problems. Okay. Right. Good. That's very good. Good. All right. All of you see here now. Yesterday I told you that there will be first type of problem which was going to be regarding the simple types of problem, where one reactant is given, one product is asked, or one product is given, one reactant is asked. Today we are going to do second type of problem which is relating to limiting reagents. So write down the heading, limiting reagent related problems. How to do these problems we will see now. Okay. How to do these problems we'll see now. So yesterday I told you this particular example, that our equation was 2 sandwich react with 1 cheese to give 2 breads react with 1 cheese to give 1 sandwich. This was the stoichiometry. Now how to know who is a limiting reagent? See, this was the simple example. Correct? I gave you 10 breads, I gave you 3 cheeses, and you said, sir, because breads are too many, only 6 breads will be used here and rest 4 breads will be excess. So this is easy to check. But what if I give you, let's say 10 gram of hydrogen reacts with 80 gram of oxygen, something like that. If I give you 10 grams of hydrogen reacts with 80 grams of oxygen to give water, then who is the limiting reagent? Will we be able to predict directly? What do you think? Looking at this, who do you think is the limiting reagent? When I say 10 gram hydrogen react with 80 gram oxygen, who do you think is less in amount? Who do you think will finish up first? What do you think? Just try to think yourself, just as a random guess you can give me. Whether H2 is in less amount or O2 is in less amount, who you think will finish first? Who will finish first? Okay. Most of you are saying hydrogen. Most of you are saying hydrogen. But here oxygen is in limiting amount. Okay. This is actually the limiting reagent. This is limited amount. Okay. Now how did I say so fast? I'll tell you the way. I'll tell you the way. All of you see here. Okay. So here H2 is not limiting reagent. No. O2 is the limiting reagent. I'll show you how. We'll see all these questions in some time. So by just looking at the mass, don't say who is limiting, who is not limiting. Okay, you cannot say like that. Okay, you cannot say like that. So you can see here how to check the limiting reagent. So first we'll write down what is limiting reagent, then I'm going to tell you how to check limiting reagent. So write down limiting reagent. You can write this definition first, then I'll tell you how to check limiting reagent. Same question I'll be telling you. Okay, 10 gram hydrogen, 80 gram oxygen, we'll do that after some time. Limiting reagent, or I'll call it LR. Okay, when I say LR, I mean to say limiting reagent. It is the reactant which gets consumed the earliest in a chemical reaction. The reactant which gets consumed the earliest means the one which finishes the first. The one which finishes the first. As soon as limiting reagent will finish, reaction will stop. So we will mention this as point. Reaction stops when limiting reagent finishes. Obviously, if the breads will finish, along only with the cheese, how will you be able to make the sandwich? You can't make the sandwich. And if cheese will finish, only with the breads also we can't enjoy the sandwich. So whenever one of the reactant will finish, the reaction will stop. Okay. What is excess reagent then? Excess reagent means the one who does not get finished completely. It is remaining after the reaction. So anything which remains in excess. Excess does not mean more in mass, and that is excess. I told you, 10 gram hydrogen, 80 gram oxygen. 80 gram oxygen does not have to be excess. It may be, but I'll show you that here oxygen will not be excess. 10 gram hydrogen actually is the excess one. I'll show you. So excess reagent is the reactant. Reagent means reactant only, okay? The reactant which remains unreacted after reaction as well. Okay, so one of the reactant will finish, one of the reactant will remain. If both are taken in perfect amount, both will finish. Okay, if both are taken in perfect amount, if I give you exactly 10 sandwich, if I give you exactly 10 bread slices and 5 cheese slices, then both are going to be, okay, then both are going to be the limiting reagents. 10 breads, 5 cheese, both will finish together. Okay. Now how to check limiting reagent? All of you see here, write down. How to find limiting reagent? Simple. Step 1. Find given moles or find moles of reactants. So never try to find limiting reagent by directly looking at the mass or directly looking at the volume. Okay, first find the moles. What are moles? We know three formulas of moles we have seen: weight by molar mass, or volume by 22.4 liter at STP, or molecules given by Avogadro number. 3 ways to find the moles was there. So when a mass is given to you, find moles. When volume is given to you, find moles. When molecules are given to you, find moles. Step 1. Once you have found the moles, step 2 you go for divide these moles by the stoichiometric coefficient. Stoichiometric coefficient is what? Whatever number comes in front of that reactant. Okay, N2 plus 3H2, 2NH3. So stoichiometric coefficient of nitrogen is 1, hydrogen is 3, 1 and 3, like that. So second step is divide moles by stoichiometric coefficient. By stoichiometric coefficient means you have to do mole divided by stoichiometry. Mole divided by stoichiometry. Once you divide the two, whichever number is smaller, okay, whichever number comes out to be smaller, that is the limiting reagent. Okay, so step 3, mole by stoichiometric smallest value is limiting reagent. Wherever the moles by stoichiometry value comes out to be smallest, that person is going to be limiting reagent. Okay. Once you know limiting reagent, full product will only depend on the limiting reagent. Then forget about excess reagent. Tell to excess reagent that you are useless for me. I will decide my product only according to limiting reagent. So if I gave you 5,000 breads, but one cheese slice. If I give you 5,000 breads and one cheese slice, breads are useless. We'll say cheese you decide. So one cheese will say, okay, one sandwich only I'll make. Like that. So step 4, the final step you can mention, which is going to be, you can mention this, that calculate the amount of product only using limiting reagent. Step 4. Calculate the amount of product. Calculate the amount of product only using limiting reagent. That's all. Okay. Now I'll be showing you the problems. Okay. So whenever data of all the reactants will be given to you, first thing you will do is you will find limiting reagent, and then you will throw the excess reagent. That I am not worried about the excess reagent. Only looking at the limiting reagent, we will find the amount of product form. Okay. Let me show you one example now with the simplest example. Let us see one thing. All of you can see the first question. You can write it down quickly. Those who still have not liked the video can do the thing. Now see here everybody. This is the very first question. Write down question number 1. Question is, for a reaction A plus 2B gives C, that is the stoichiometry of reaction A plus 2B gives C. Now they say 5 mole of A react with 8 mole of B. How much C will form? So can you see here that data of both the reactants is given. Amount of A is also given, amount of B is also given. So you will write the reaction, you will say that A plus 2B gives 1C. So stoichiometric coefficients are 1, 2, 1. Stoichiometric coefficients are 1 to 1. Next thing, you find given moles. They directly gave us the moles only, 5 and 8. 5, 8. Okay, moles are given 5 and 8. By looking at the moles, you might feel, sir, this is a limited amount. No, this is not limited amount. Always, who will tell you limited amount? Moles by stoichiometry. Now, to find LR, do moles by stoichiometry. Just to check LR. Okay, just to check LR, I'll do moles by stoichiometry. So his moles given are 5, his stoichiometry is 1, 5 by 1, which is 5. Which is 5. Yes. And B is 8 moles by stoichiometry 2, which is 4. So this is 4, this is the lower number, this is the limiting reagent. As soon as you have written the LR, circle the B and say, you are limiting reagent, you decide everything. B decides everything because B will finish first. B will finish first, so B decides everything. Yes. Now just say that when B is 2, you can get 1 mole of C. So we'll say 2 mole B produce 1 mole C. So 8 moles of B are given, no, 8 moles. So 8 moles of B, which is given moles. Forget about this. This was just a calculation you have done to find LR. Then don't use it. Just cut it down later. Once you have found the LR, these 5 and 4 number are not important for you. Okay. These are just to check the LR. 2 mole B produce 1 mole C and 8 mole B produce how much? So 8 mole B are going to produce, 1 will produce 1 by 2, 8 will produce into 8, 4 mole C. This is the first question. Correct? Second option, very good. Okay, simple. Is it simple, yes or no? Every time you have to do this. If mass is given, you will first find moles, you will divide moles by stoichiometry, and then you will decide the limiting reagent. From limiting reagent, you will decide the product. Is it clear, yes or no? Is this clear? 3 steps, 4 steps, everybody is clear with this? Yes. So first question was a simple one, directly moles were given. Now let's try that question that I told you. 10 gram hydrogen, 80 gram oxygen. Let's do that one. Okay, another question, let's. Yes. Okay. Let's do another one. Write down the question, question number 2, you can write it down. 10 gram hydrogen reacts with 80 gram oxygen to produce water. Question is, calculate mass of water produced. Okay, this one also I will show. From the next question, I'll ask you to do. From the next question, I will ask you to do. All of you can see here. So, reaction I'll write first. Reaction is H2 gas plus O2 gas give H2O liquid. First thing, let's balance it. 2 oxygen, so I'll make it 2 water. 4 hydrogen, so I'll make it 2 H2. Stoichiometry is 2, 1, 2. This is stoichiometry. Then I'll find given moles. Never start with mass. Given moles. Moles. Since here mass is given, masses are given, in terms of mass, moles can be written as weight by molar mass. So moles of hydrogen are given 10 gram by 2 gram. 10 gram by 2 gram moles are given. And for oxygen, 80 gram by 16 gram. Okay, 80 and 16. Correct? By 32, sorry, not 16, by 32. So actually I gave you both the things in the same amount. If you see here, molar mass of O2 is 632. Okay, so 80 by 32. So if I see here, this comes out to be 5 moles. This comes out to be 2.5 moles. This comes out to be 5 moles. This comes out to be 2.5 moles. So to check limiting reagent, I am checking limiting reagent. I am doing given moles by stoichiometry. Moles upon stoichiometry. Moles upon stoichiometry. So it is 5 moles by stoichiometry 2. This is 2.5 moles by stoichiometry 1. Now both are 2.5, 2.5. This is also 2.5. This is also 2.5. Both are limiting reagent. Both are limiting reagent. Both are limiting reagent, yes. So you say any one of you can decide. Both will finish together. Yes, good. 90 gram is correct answer. 90 gram is correct answer. So you can say both are limiting reagent. Anyone can decide. Anyone between hydrogen and oxygen can decide. Okay, so both are limiting reagent, both are finishing together. It's almost like saying I gave you 10 breads and 5 sandwiches. Both are limiting reagent. So what I have done, again I am telling, masses of hydrogen and masses of oxygen were given. Mass is not useful to find the limiting reagent, moles are useful. So first thing I did, I found the moles. Moles of hydrogen, 10 gram by 2 gram, 5 moles. 10 gram by 2 gram, 5 moles. Okay. And for oxygen, 80 by 32, 2.5 moles. So I wrote the given moles. Moles are 5 and 2.5. 5 and 2.5. 5 and 2.5. Next thing, to find who will finish first, I am doing moles by stoichiometry. 5 by 2, 2.5. 2.5 by 1, 2.5. Both come out to be smallest. Means both are limiting reagent. You say any one of you decide. Now let them decide. So let's take hydrogen. 2 mole of hydrogen produce 2 mole of water. 2 mole hydrogen produce 2 mole water. 2 mole water, can I also write 36 grams because each mole of water is 18 grams. So I can say 2 mole hydrogen produce 36 gram water. And here what hydrogen is taken 5 moles. So we'll say 5 mole hydrogen will produce 36 by 2 into 5, that is 90 gram. 18 5s are 90 gram. That is the amount of water. That's correct. Both are limiting reagent here. Yes, that is correct. That is correct. Is it clear? Sir, why not 10 by 4? What 10 by 4? No, beta. Moles formula is fixed, no? What is the formula of moles, Lasya? Moles formula is mass by molar mass. What is the molar mass of H2? It is 2 gram. What is the meaning of moles? Mass by molar mass. No matter here 2 is there. What is the molar mass of hydrogen? 2 gram. Okay? 2 gram. So that's why to find the moles of hydrogen, forget about this 2. Forget about this 2. 10 gram hydrogen means how many moles? 5 moles. Okay? Yes. Alright. Let's do one more. So here there was no limiting reagent. Both of them were equally limiting reagent. Let's do one more. All of you can see here. Let's see this one, all of you. One more I am telling, then next you can try. Question is, when 22.4 liter hydrogen is mixed with 11.2 liter chlorine, moles of HCl formed are how much? Moles of HCl formed are how much? Okay. So, what is the reaction? H2 gas combines with Cl2 gas to give 2 HCl gas. This is the one. 1, 1, 2 is the stoichiometry. 1, 1, 2. So stoichiometry is 1, 1, 2. Second thing, find given moles. Okay. Find the moles. So I am writing moles. Moles, in this case, volume is given. volume is given. So when volume is given, which formula of moles you will use? You will use the formula volume by 22.4 liter. That is the formula of moles. So hydrogen is 22.4 given volume by 22.4 molar volume. And for chlorine, 11.2 given volume by 22.4. So his moles are 1, his moles are half. His moles are given 1, his moles are given half. To find the limiting reagent next, I will do moles divided by stoichiometry. His moles are 1, his stoichiometry is 1 by 1. His moles are half, his stoichiometry is 1, half by 1. This becomes the limiting reagent. This becomes the limiting reagent. So chlorine, you decide. You are the LR, you are the king, you decide. Chlorine, you decide. Chlorine, you are the king, chlorine will decide. Now, chlorine says, when I am 1 mole, I will give double HCl. 1 mole chlorine produce 2 mole HCl. 1 mole chlorine produce 2 mole HCl. How much chlorine is given to you? Half mole is given. Half mole is given. Reddy Raghava, 32 was the molar mass of oxygen. That's why we took. 1 give 2, half give 1. So 1 mole chlorine produce 2 mole HCl. Half mole chlorine, which is given to us, produce 2 into half, which is 1 mole HCl. That is the answer. These are the types of question which NEET asks. These are the types of questions which NEET asks. Again, I am explaining. You can see once more. Up to limiting reagent, I hope to everybody it is clear. I hope to everybody up to limiting reagent it is clear. I found that chlorine is the limiting reagent. After we have found chlorine is the limiting reagent, we'll say chlorine, you decide everything. Chlorine says when I am 1 mole, HCl are 2 moles. 1 chlorine give 2 HCl. Okay. How much chlorine have we started with? We have started with half chlorine. This is the given moles, no? These are the moles you started with. So 1 give 2, half give 1. 1 mole HCl. Let's do one more, everybody. Let's do one more, yes or no? Just write more, then we'll do one more. Just write more in the chat box and you will do the next question. Sir, how you got 2 moles? Beta, it's a stoichiometry. This has nothing to do with our question. This is just the stoichiometry. 1, 1, 2. Just balancing I have done. Next one. Do this, everybody. Do this, all of you. Let me see how many of you get it correct. One minute I'll give. Okay, time almost up. Time is almost up. Sir, equation. Sahiti equation. This is a double displacement reaction, as you have studied before. Double displacement reaction. Reaction is this. Then remember this afterwards. Barium chloride reacting with sodium phosphate. BaCl2 reacts with sodium phosphate Na3PO4 to produce. So sodium goes with chloride, double displacement. Just exchange the cation anions. Barium plus 2 goes with phosphate minus 3. So barium phosphate. Barium charge is plus 2. So valency of barium goes to the foot of phosphate. Phosphate charge is minus 3, goes to the foot of barium here. Ba3PO4 plus NaCl. Plus NaCl. This is the double displacement reaction or double decomposition also you have studied. Have you all studied precipitation reaction? I hope yes. Yes. Now balance it. 3 barium, let me keep 3 barium chloride. Barium balance. Now chlorine became 6. So let me take 6 NaCl. Chlorine balanced. 6 sodium and here only 3 sodium. Let me make it 2. So now there are 2 phosphates, 6 sodiums, 3 bariums, 6 chlorines. 3 bariums, 2 phosphates, 6 sodium, 6 chlorine. This is the balanced equation. So stoichiometry becomes 3, 2, 1, 6. 3, 2, 1, 6. 3, 2, 1, 6. Now given moles. Have they given us moles? Yes, they gave us directly moles. Half of this given and 0.2 of this given. Correct? These are the given moles. Now, to find limiting reagent, I am doing moles by stoichiometry. 0.5 moles by stoichiometry is 3. 0.2 moles by stoichiometry is 2. Okay, when I divide it, it is almost 0.166. This is 0.166. 0.166. This is 0.1. This is the small number. He is the limiting reagent. Na3PO4, you are the king. You decide everything. Na3PO4, you are the king. You decide everything. So Na3PO4 says, okay, I will decide. You can cut this limiting reagent part. After you have found the limiting reagent, no, then don't be confused. This part, just cut it, that I don't want to use this anymore. Once I have found the limiting reagent, I don't need this calculation. Na3PO4 says, I will decide when Im2, barium phosphate is 1. So 2 mole sodium phosphate give 1 mole barium phosphate. 2 give 1. So 0.2 will give 0.1. 0.2 mole sodium phosphate should give 1 by 2 into 0.2, which is 0.1 mole. That is the answer. Please tell me, is it clear to everybody or not? Third option. Is it clear to everybody or not? Thank you. Is it clear to everybody or not? If it is clear and you have got the correct answer, quickly like the video. If you have got the correct answer, quickly like the video. Sir, why are you doing divide by 2? Beta, here is 2 na. Moles by stoichiometry I am doing, no Sahiti. Moles by stoichiometry I am doing. Na stoichiometry is 2, that's why I am dividing by 2. Moles given divided by stoichiometry. Moles given divided by stoichiometry. Thank you very much. If you are getting it good. Shall we do one more? Shall we go for one more? Yes. Go for this then. 100 gram H2, 100 gram O2. How much water will form? Many of you will try to act smart here and say, sir, law of conservation of mass, 100 gram, 100 gram, 200 gram. Never do that. Never do that. You don't know the reaction is complete or not. Okay. Law of conservation of mass is always valid, yes. But all the reactants never convert to product. Final mass will remain 200 gram, but in that 200 gram, all will not be water. Some of the excess reagent will remain. No? Easy method to balance, just hit and trial. No other easy method to balance. Balancing of reaction, just hit and trial. Do this. Devarya is saying 25 gram. 1 second, what was the question? Yeah, this is the question. Mention the answer and also mention comma the limiting reagent. If your limiting reagent is H2, mention H2. If the limiting reagent is O2, mention O2. (113 gram), some are saying 50 gram. Who is the limiting reagent? Chalam D. Who is the limiting reagent? Venkateshwarlu. Akshara. Limiting reagent also I need. A you are saying, most of you are saying A and C. Some of you might have got wrong limiting reagent, that's why your answers are different coming. Some are saying H2, some are saying O2, 200 gram, Venkat is saying 200 gram. Okay, let me do now. All of you can see here. First thing, reaction. Hydrogen gas plus oxygen gas give water liquid. Balance. 2 oxygen take 2 water, 4 hydrogens take 2 H2. Stoichiometry. 2, 1, 2. Okay. Then moles given. Moles, because weight is given, I'll find the formula of moles as weight by molar mass. 100 gram hydrogen was given to you, so moles of hydrogen are 100 gram by 2, because molar mass of hydrogen is 2 gram. 100 gram by 2 gram, 50 moles are given, 50 moles. For oxygen, 100 gram was given, molar mass is 32 gram. Okay, so moles are how many? Moles are, just I'll keep it as a approximate value only. Moles are going to be on the table of, cut it on the table of 4. It is 25 by 8, 25 by 8, and 25 by 8 is nothing but 3 point, okay, here I am doing the calculation, you can see here, 100 by 32 means 25 by 8, which is nothing but 3.15. 3.15. So this is 3.15. 3.15 moles. Next thing is to find the limiting reagent. Do moles by stoichiometry. How many moles? 50. What is the stoichiometry? 2. 50 by 2. Here 3.15 by 1. 3.15 by 1. Stoichiometry is 1. Obviously 25 is large number, 3.5, this 3 is a small number. This is the limiting reagent. Now cut this part, you are not concerned with this. Oxygen, you decide. Oxygen is the king. I am the king, I will decide. Okay, then oxygen says, when I am 1 mole, I produce 2 mole water. I produce 2 mole water. 2 mole water means 36 gram water. So we'll say to 1 mole oxygen, 1 mole oxygen gas produce 36 grams water. Okay, but how much they gave us? They gave us 3.15 moles. So one produced this much, 3.15 mole oxygen produces 36 times 3.15. Okay, 36 times 3.15, which comes out to be 113 gram around. So 113 gram. That is the answer. Good. Those who have done correct. Answer is 113 gram, and oxygen is the limiting reagent. Oxygen is the limiting reagent. Sir, please explain the last portion. Last portion, I am just looking at the reaction beta. 1 mole oxygen produce 2 mole water. 2 mole water can also be called as 36 grams of water. Okay, yesterday we did, no? Yesterday we did. 2 mole water can be written as, here, just see here. This 2 mole water can be written as 2 times 18 gram water, can be written as 2 Avogadro water. Anything I can say, no? Either in terms of mass I can say 36 gram, in terms of moles I can say 2 moles, in terms of molecules I can say 2 Avogadro. Yes, so I've just said that 1 mole oxygen produce 36 gram water, 3.1 give 113. Are you all ready to do one more question? Yes or no? Are you all ready to do one more question? Just mention ready, like the video, then I'll give you the next question. Like the video, say we are ready, and then we will start the next question. Yes, okay. Do this one. Or let's do a different one. This question you can do. Question is, 30-liter hydrogen gas reacts with 15-liter nitrogen gas. Find volume of ammonia gas released or produced at STP. 30-liter hydrogen reacts with 20-liter nitrogen, 30 with the 15-liter nitrogen, 30 hydrogen, 15 nitrogen. Then calculate the volume of ammonia produced. Let's keep it as your homework. Give your time to this. Tomorrow I will discuss. Tomorrow first thing I'll discuss this one. I'll give you 2 minutes. If you have the answer with you, you can just answer it in the chat box, or I'll solve it tomorrow. Okay, chalo. See you everyone. I hope you have enjoyed the class today as well, and I'll see you all in the next class. Bye bye. Thank you. You can keep doing it. Okay, and just tell the answer. Some people are saying 20 liter. Tomorrow I'll check. Tomorrow I'll check whether it is 20 liter or not. Easy problem. That's good. Okay, good.